All right, 7A, this is 7A practice. So this is working with polynomials. So first we're gonna look at local minimums and maximums. Local minimums just mean within the graph there's a low point, kind of like a bottom of a vertex, but a low point, and usually it's just a low point within the graph, not the lowest point of the graph, but the low point within the graph. And we're just going to estimate this. I'll say it's at negative 1 point, we'll say 8, and the y value is negative 2.1. So that'd be negative 1.8, negative 2.1. All right, and then local maximum, then again, it's a little high point within the graph, not the actual high point of the graph, the high coordinate. It's a high point within the graph. This one we don't have to estimate. It looks like it's right on the interval negative 3, negative 1. Domain. Domain is how far left does the graph go to how far right. So I look at the left part of the graph, the left end of the graph, and it looks like it's going left forever. And as I follow the graph, it's going to go to the right, still going to the right. It's never going to stop going to the right. So that'll be negative infinity to the left, to positive infinity to the right. Range. We're going to look at from how low does the graph go? I look at the low end of the graph. The low end is going down forever. That's negative infinity. And as we follow it, it goes up and down. It has those little local maximums and minimums, but the actual maximum of the graph, how high it goes up to positive infinity. So the range will be negative infinity to infinity. And both of these, you could represent it as this symbol here. That's X is all real numbers. So you could write it like that also. Little backbone R that says all real numbers. Looking at increasing and decreasing now. To look at increasing and decreasing, we need to first label the graph. So labeling the graph, start on the left side and work up the graph. So first part is increasing. Then the graph turns, and let me do that in a different color. So the graph turns and decreases. So just a little interval of decreasing, and then right back to turns and goes back up, and it's increasing again. So we have 2 increasing intervals and 1 decreasing interval. So we are looking at the X values. So this is where the local mins and maximums really come into play. You're looking at your X values of the local minimums and maximums. That was negative 1.8, we said. So the X values, I'm not looking at the Y's at all, just the X values when increasing and decreasing. It's kind of like the domain of those. So the increasing portion, the first part, how far left does that go? It goes to negative infinity. So this first part is negative infinity. And where does that stop increasing? It stops increasing at negative 3. So increasing from negative infinity to negative 3. Also, our next part starts increasing at negative 1.8. So negative 1.8. And then where's the stop? Stop never. It'll keep going to the right forever to positive infinity. So negative 1.8, positive infinity. And you can put a U in between to say that they're both parts of the increasing intervals. Decreasing, just a tiny little part. Starts decreasing at negative 3. So that's negative 3. And where does it stop? Negative 1.8. So negative 3, negative 1.8. So now let's look at end behavior. That's what our next part is. So you're looking at the ends of the graph. So this end of the bottom end of the graph is going to the left forever. So X is going to the left forever to negative infinity. The Y value, where is it going? The Y value is going down to negative infinity. So that's the top one here. This f of X is Y, and that's going to negative infinity. On the other end of the graph, that is going in 2 directions. It's going to the right forever, which is X is going to positive infinity. And it's going up forever, which is Y value is going to positive infinity. So X is going to positive infinity, the Y value is going to positive infinity. Now I'm going to erase this so we can look at our X-intercepts, which are also called roots, solutions. X-intercepts looks like we only have one. We'll say that's 0.9 or negative 0.9. The Y-intercept looks like it does have a Y-intercept that we can see. Now there could be a Y-intercept that is off the graph. Excuse me. But so you'd have to estimate it. This one I'm going to estimate it at 0.8, or you could just say 8. I'm good with that. Number 2, we have to actually draw this. So you're going to put it in a calculator or in Desmos, put the function in. And what we're going to do is we're going to get some coordinates from this. Now the coordinates you would get, pretty much get any coordinate you possibly can. And Desmos does a really nice job with looking at or giving us some good coordinates like 0, 1. That's the Y-intercept. And we'll, boy, that's a really small one. So 0.10 is an X-intercept. Our local minimum is negative or positive 1, negative 4. Another X-intercept is at I'm just going to round it to the tenths, 2.20 and 4.70. So there's 3 X-intercepts in this one. There's a local minimum. There's another local max here. So 3.7, 5.5. And we're just going to take a general shape of the graph. And then so when we connect the points, we know that it starts in the top left and then it goes down to the bottom right. So let's go back to the graph, and I'm going to put all those coordinates. I just wrote them down separately. I know you couldn't see that, but I'm going to put all those coordinates on the graph. So we have a Y-intercept of 0, 1. We have a X-intercept of 0.10, so it's right, I mean, you can, if you did at 0, 0, I'd understand that. Another X-intercept at 2.20, and 4.7, so that's almost a 5, 0. The local minimum is at 1, negative 4. The local max is at 3.7, 5.5. Somewhere up here. All right. Now I'm going to take one glance back at the graph to see what's going on. All right, we're going to start top left, go through the Y-intercept, through the first X-intercept, down to the local min, and then back up, back down again. All right. So we're going to start top, come down through the Y-intercept, keep going through the X-intercept, hit that local minimum, turn around, go back up. Oh, missed it a little. Hit that local maximum, turn it, back down, and there you go. Doesn't have to be a perfect looking graph, but it's a general shape of the graph. You're estimating the points. So our local minimums, we had one at 1, negative 4. Local maximum, we had one of them at 3.7, 5.5. Domain, how far left to how far right does that graph go? Well, it goes to the left forever and to the right forever. So negative infinity, infinity. Again, you can put the all real numbers. Range, it's going down forever. And as you follow the graph, it'll go up forever. So negative infinity to infinity, meaning all real numbers. So you could have either one of these written down. All right, increasing, decreasing. Now we need to actually label some things. So starting on the left, as you go down, that is decreasing. And then we're going to turn. And you're going to increase. And then it's going to turn again. Graph's going to turn again, and it'll decrease again. So we have 2 decreasings, 1 increasing. So let's just label them. We'll just label them. So the first decreasing portion, how far left does that go? It goes to the left forever. So that'll be negative infinity. And how far right does it go? We said that was at negative or positive 1. Negative 4. So positive 1 is what we want. So positive 1. The second portion, the increasing portion, is from positive 1 to, and it goes all the way to, that was at, the local max was at 3.7, 5.5. So the 3.7 is what we want, the x values. You're really naming the domain of the increasing or decreasing portion. And the last part, decreasing, starts decreasing at 3.7. And where does it stop decreasing? It keeps going to the right forever. So right forever is positive infinity. All right, let's transfer those down. So we have increasing interval, from 1 to 3.7. Decrease intervals has 2 of them, negative infinity to 1. And we're going to join that together with 3.7 infinity. All right, end behavior. 2 end behaviors of the graph. You have the left side. It's going 2 directions. It's going to the left forever, which is x is going to negative infinity. And it's going up forever, which is going y is going to positive infinity. And so that's the top one. The bottom here is going to the right forever. X is going to positive infinity. That's right forever. And it's going down forever. So the y is going to negative infinity. All right, X-intercepts, we already have those. We can name them all. You can put them as coordinates, or you just label them out. 2.2 and 4.7. Again, I'm just doing them to the 10th place. Y-intercept was at 0, 1. You can, again, label it as a coordinate if you want, or you could just have 1. That'd be fine. All right, next we have the graph already graphed. So we have, I'm just going to name my local maximums. So that's negative 1, 1. Local minimums, so 0, negative 1. This one we're going to have to estimate at 1 point. I'm going to go with 9. You could go 8. That'd be fine. Or you could estimate it at 2. 7.4 is what I'm going to estimate it at. All right. And I guess we have to do X-intercepts. So that'd be about negative 1.5. What's that middle one going to be at? About negative 0.8. This one here is at 0.5 about. This is at about 2.5. A lot of X-intercepts, 4 of them. So local minimum is 0, negative 1. It's a local minimum. Within the graph, there's a little low point. Maximum, there's a little high point at 1, negative 1, 1. Domain, how far left is how far right does the graph go? It goes to the left forever, and as you follow the graph, it'll continue to the right forever. So that will go to negative infinity to infinity. Anytime there's a continuous graph from left to right, it'll always be, the domain will be negative infinity to infinity. Range. All right, here this is a tricky one. So at range, start at the lower level. They're both low, going down forever. And as you follow it, what's the highest point? Well, the highest point is up here at this maximum. Oh, I totally missed that. That's another local maximum. My goodness. So there was another local maximum. My bad. But the range is also going to be up to that's the maximum, the highest point of the graph that it'll ever be reached. So the range goes from negative infinity, both ends go down to negative infinity. It only takes one, just negative infinity, and the highest point y value is going to be at 7.4. There's an actual point there, so we're going to close it off with a bracket to say it's included. Intervals of increasing and decreasing. So we have different parts of increasing, different parts of decreasing. So the first part of increasing is negative infinity to, so increasing, Then it's going to go back to decreasing a little bit. This little portion is decreasing. Then it's going to go back to increasing. And then it's going to go back to decreasing. So there's going to be 2 of each. 2 increasing, 2 decreasing. So the first part of increasing is from negative infinity to -1. And then there's another increasing from 0, always x values, to, yeah, I said 1.9. Whoa, what happened? I'm going to put a u in there just to say they're joined together, both parts of it. Decreasing is from -1 to 0, and 1.9 to, and it's going to go, this is 1.9, is going to go to the right forever to infinity. End behavior. Oh my goodness. Well, let's do the x-intercepts and y-intercepts, then I will erase those. So the x-intercepts, -1.5, I have it as 0.8, 0.5, and 2.5. As long as you estimate it somewhat close, you're good. Y-intercept is at -1. I'm just going to put 0, -1. All right, now I'm going to erase this so we can look at end behavior. Just the ends of the graphs. What's the deal with those? This first end is going to go to the left forever, also slightly, very slow, but it's going to go left forever, which is negative infinity, and it's going to go down forever to negative infinity. That's the first one. Second one, which 2 directions is it going? It's going to the right forever. Right forever is x is going to positive infinity. What's the other direction it's going? It's going down. It's going down forever. Down forever is to negative infinity. So there you go. All right, number 4. I'm gonna have to put this in the calculator. All right, so going to Desmos. Put this in the calculator quick, hopefully somewhat quick. X to the 4th, so that's a to the b is what I'd press to get to any exponent I want. Minus 3x squared minus 2x minus 2. Okay, so let's get some coordinates from here. So I'll look at x-intercept is, we'll round it to -1.6. Another x-intercept is at 2.1. We have a minimum, local minimum at -1, -2. Another, our local max, tiny little hill there, but it is -0.4, -1.7. There's another minimum at 1.4, 6.8, -6.8. And what else? What other point do I have? A y-intercept. So this is really just got to be very careful how you put them into the graph to make sure you have, or put your equation in to make sure it all lines up, all the positives and negatives are right. And then it's just paste it over. It's going to be kind of a wonky W looking graph. X-intercept is at -1.6. Oh, I almost just wrote with an actual pen. Oh my goodness. -1.6, 2.1 has a minimum at -1, -2. Has another minimum at 1.4, -6.8. So right here. Has a maximum at -0.4 and -1.7. Just try to do your best to get a graph that looks right. And a y-intercept at 0, -2. There's a lot of points that are close to here. I'm going to go back to the graph and make sure I look at it to kind of get the idea of what it looks. So it starts on the top left, and it's going to go down, minimum, maximum, through the y-intercept, down to the minimum, back up top. And it's going to end positive. So we start up on the left. It's going to go through the x-intercept, minimum, back up to a maximum, down back to the minimum, quick swing back up to the maximum, or the x-intercept, and back up. Then it's going to end up in up. So it's kind of a wonky looking W. All right, local minimums. There's 2 of them. We had those labeled already from the graph, and you can certainly do this before you draw it. And -1 -2. Maximum. The domain. Well, let's go into the left. And the graph's going to be continuous, and it's going to go to the right forever, so -infinity to infinity. The range, got to be careful here. The range is going to go up to positive infinity, but as you look at the graph, the lowest point of the graph is here. And that lowest point, the y value is, so x is -1.4, but we want the y value since that is the range. That is going to be the lowest y value of the graph, so we're going to start at the low at -6.8. Close it off with a bracket because there's an actual point here, closed point, saying it's included. And then looking at the graph, the left side goes up forever, the right side goes up forever. So there's no limit to how high it can go, so it's going to go up to infinity. Increasing, decreasing. Oh my goodness. Oh no, I guess I can erase all that. All right, so increasing, it's going to increase. There's a tiny little portion that increases right there. That's going to increase from -1 to -0.4. Where else is going to increase? It's going to increase from -1.4 to the right forever to infinity. Where's it going to decrease? It's going to decrease from the beginning, from -infinity to -1. And where else is it going to decrease? It's going to decrease from this little local maximum here at -0.4 and all the way down to -1.4. End behavior, both ends of the graph. The left end is going to go left forever to -infinity. The y is going up to positive infinity. And the right end is going to go to the right forever. This arrow is going right, which is positive infinity, but it's also at that point, same, it's going to go up to positive infinity. So both of them are positive infinity. Both ends are going up to positive infinity. X-intercepts, we already named those. There's 2 of them, -1.6 and 2.1. Y-intercept is at 0, -2. And that is 7a. Hopefully this helps you.